Otherwise, here we will discuss the general mechanical design in the top fired. In the top fired, generally, I want to clear to you that the huge number of tube of the catalyst may be more than 400, as we see here in this slide, with number of row maybe 8, okay, and the pressure is around 41 bar with exit temperature for the bridge wall maybe more than 900 degrees C, okay. This is the shape of the top fired reformer. This is for real from the side, okay. And here you can see the steam drum, inlet of the stream and outlet of the stream, and heat recovery in this exchanger and producing high pressure steam in the steam drum like this. And in the side, you know that for each stage here you have a bib hole to skin temperature measurement for the tube of the reformer, okay. Also, this is another case for the top fired reformer. This is maybe in Italy or something like that. And here, as we mentioned, the peep hole. And this is the common header for the feed, as we mentioned, to keep the delta B for the reformer stable and measured and controlled through the process. This is another Lindy reformer technology, top fired also, maybe in the United States or something like that. Okay. Here, reformer technology, top fired reformer in India. As we see here, the distribution of the tube, you must have a good distribution for the tube and the burner organized. Okay. This geometry is very, very important to stabilize giving this heat to the tubes. As we mentioned before, the reaction is endothermic, okay. We discussed three main type of the mechanical design of a reformer. As we mentioned, the top fired reformer here in the shape, and the side fired reformer and the terraced wall. And we need to discuss what is the advantage and disadvantage for each type of mechanical design. As you will see, or you will remark that the top fired, the regular rectangular box, this is as usual top fired. Here, long narrow box for the side fired, and for the number of the cell, you have one cell for all the tube. Here in the top fired, you have one single cell for all the tube. Here maybe single or multiple, okay. The tube arrangement, several parallel rows, as we know. Here, one row per one cell, okay, one row per one cell. I want you to imagine if you are working with this side fired, how you will control the temperature. You have to work with one row per each one cell, okay. The process flow is down here, also down here, and the flow gas is co-current in the same direction of the flow inside the tube. You have the flow gas from the burner in the same direction, but here counter current in the side and the terraced design, it will be counter current as we mentioned before. The convection section horizontal at grade vertical alongside the box, here elevated above the radiant vertical down. Balanced or induced, the draft here in the top fired will be balanced or induced because the direction from top to bottom, this is the direction of the flow. So recommended to be balanced draft, okay. But in the side or terraced design, here you will work with induced, and you have the capability to work in the low capacity design with the natural draft, okay. What is the main item you have to consider when you make the selection process between each design? The maintenance cost. If you want to have minimum maintenance cost, you have to go with the top fired, and you have to be away from the side burner design. Here the control complexity, it will be very, very complex related to the side fire. Why? Because for each row, okay, we have a number of burner servicing this each row, but you have all the tube here only in one room or one cage or something like that, okay. Number of burner, huge amount will be in the side and the terraced in comparison to the top burner. Why I want to clear this? Here, for each row, you have to install a fixed number of burner. So you expect a huge number in this side fired or terraced wall reformer. Okay, as we mentioned here, the number of burner, it will be too much here. and too much also in terraced design. But in the top fired, it will be minimum. The burner access easy in the top fired for sure, okay, and little bit difficult in the terraced or D side. Piping mass will be easier here in the top fired in comparison to the terraced and side fired. The surface area, you have a good surface area in the top fired, okay. Natural draft, as we mentioned, can be applied in terraced and side fired, but cannot be applied in the top design. Heat input control along, no, yes, yes, as we mentioned. Investment cost, this cost is higher, and this is little bit down, and the best choice is the top fire. Ease of expansion, this is the only disadvantage related to the top, because you have to install maybe hanger support for each one tube related to the process stream, okay. So this or this will be much easier, and here in the top fire much difficult. But the summation of the facility easier and difficult, it will be in the right of the top fire. For this reason, you understand now why in the major hydrogen production plant generally we find in the refinery or in the petrochemical plant, we in the majority of plant we choose the top fired reformer. Here now you understand why we, because good burner access, good piping mass, the distribution of the burner, the maintenance cost, all these items clearly in the side of the top fired design, okay.